Good afternoon, children. So today we are going to talk about acids, alkalis and titrations. So in this chapter we learn about indicators, acids and alkalis. And also we are going to learn how to do a titration. The reactions of acids are also discussed in this chapter. So objectives. So after studying this chapter you should be able to fulfill these objectives. First one is to describe the uses of litmus, phenolphthalein and methyl orange to identify between acidic and alkaline solutions. Also to understand the pH scale, describe the uses of universal indicators, know the difference between acids and alkaline solutions, know that alkaline solutions can neutralize acidic solutions. So these will be the objectives that you should fulfill. The pH scale. So what is the pH scale? So this is a scale that ranges from 0 to 14. This scale can tell us how acidic or how alkaline a solution is. So just imagine we have a solution and we know a value for the pH of that solution. According to that value we can tell what is the nature of this solution. So if the value is in between 0 and 3 we tell it is strongly acidic. If the value is in between 4 and 6 we said it is weakly acidic. If that value is exactly 7 we said that it is a neutral solution. Neutral solution means that it is not acidic or it is not alkaline, it is neutral. So if the pH is in between 8 and 10 we tell it is a weakly alkaline solution. If the pH is in between 11 and 14 we tell it is a strongly alkaline solution. So in this slide you can see some examples for these types of solutions. So strongly acidic means pH 0 to 3. Example is hydrochloric acid. Weakly acidic means pH 4 to 6. Example is ethanoic acid. Neutral means pH exactly 7. The example is sodium chloride. Weakly alkaline means pH 8 to 10. Example is ammonia. Strongly alkaline is pH 11 to 14. Example is sodium hydroxide. Then we are going to talk about universal indicators. So universal indicators are made from a mixture of indicators. So this can change the color in a very wide range of pH values. Universal indicators can be papers or solutions, mean liquids. The best example is the full range universal indicator. In that full range universal indicator pH range is from 1 to 14, but it is said that it is not very accurate. So if we have a solution and we have a paper indicator, we can put the paper indicator into that solution and there is a color, it shows a color. So if we know the color, according to that color we can look into a chart and tell what is the value of the pH of this solution. That is basically what we do. So common indicators. So common indicators are litmus, methyl orange, phenolphthalein and universal indicator. So litmus indicator in acidic solutions it will show red color. In alkali solutions it will show blue color. Methyl orange indicator in acidic solutions it will show red color. In alkali solutions it will show yellow color. Phenolphthalein indicator in acidic solutions it will show colorless. In alkali solutions it will show pink. Universal indicator in acidic solutions it will show red. In alkali solutions it will show blue. Then we are going to talk about acids. So acids will always have hydrogen atoms. Acids contain hydrogen atoms. And the thing is these atoms can be replaced by other atoms during a reaction. Okay. The example is if we react hydrochloric acid with sodium hydroxide, you can see the hydrogen atom of hydrochloric acid is replaced with sodium. The reaction is given in the slide. So the other thing is, all the hydrogen atoms are not replaceable. In all the acids, the hydrogen atoms are not replaceable. There are some weak acids, and there are hydrogen atoms in these weak acids which cannot be replaced by any other thing. Normally when acids are in water, they dissociate. Okay, so they dissociate and they will form some ions. If we take hydrochloric acid, it will form hydrogen ion and chlorine ion. That is what happens when acids are put into water. Okay, acids in water. Okay, so measuring the pH. What is the pH value? pH value is actually related to the hydrogen atom concentrations. Ion concentration, not the atom, the ion concentration of the solution. pH is related to the hydrogen ion concentration of the solution. So we will later on learn how we can exactly find the pH if we know the hydrogen ion concentration, but just for now you should know that pH value of an acid is related to the concentration of hydrogen. Okay, so when writing pH, there is something important. When writing pH, the P should be simple, H should be capital. That is the standard way of writing pH. Bases. Bases are substances which can neutralize acids. What bases can do is, bases can neutralize the acids by combining with the hydrogen atom of the acid. So at this level we basically learn bases as metal oxides, metal hydroxides and ammonia. Some bases dissociate in water, forming hydroxide ions. These bases are known as alkalis. So alkali is, they dissociate in water, forming hydroxide ions. Okay, so you can see the reaction. Sodium hydroxide will dissociate, forming sodium ion and hydroxide ion. Ammonia will react with water and form ammonium ion and hydroxide ion. So the reactions are given in the slide. Other alkaline solution. There are some other alkaline solutions which react with water to form hydroxide ions. One example is sodium carbonate. Sodium carbonate will react with water and form sodium hydroxide and sodium bicarbonate. The reaction you should look at the slide. Reactions of acids and bases. Acids can react with bases and give neutral solutions. That is the basic concept we should remember. For an example, if we take copper oxide, it can react with sulfuric acid. So when copper oxide reacts with sulfuric acid, the copper ion will get combined with the sulfate ion and hydrogen ion will get combined with the hydroxide ion, forming water. And also sodium hydroxide can react with hydrochloric acid. In there, the sodium ion will get combined with the chloride ion and hydrogen ion will get combined with the hydroxide ion. So in those two, all those reactions, you can see a common reaction, that is hydrogen ion reacting with hydroxide ion to form water. That you should remember. In acid base reactions, that is always happening. Then titration. So titration is something we do in the laboratory. So if we have an acid, we know the volume of the acid and we know the concentration of the acid. What we can do is, we can use this acid to find the concentration of an unknown base. That is what we do in a titration. In the titration, we have a conical flask and a burette. In the conical flask, we put the acid which is concentration is known, and in the burette we put the base whose concentration is not known. So first we measure, in here the reaction we are doing is the reaction between hydrochloric acid and sodium hydroxide using phenolphthalein as the indicator. We measure out 25 cubic centimeters of hydrochloric acid using a pipette. You can see the diagram. That instrument is called the pipette. Then we put this solution into a conical flask and then we fill the burette, this large apparatus, with sodium hydroxide. We take the initial burette reading, and then we add a small amount of indicator to the conical flask, and then we add sodium hydroxide dropwise to the conical flask. So at some point you can see a color change, so we take the burette reading of that color change. So by this burette reading we can calculate the concentration of sodium hydroxide. That is what we basically do in a titration. So we have come to the end of this chapter, so you should refer the page 172 of your textbook and do the questions, so you can get a very good idea about this lesson. Thank you.